Hey everyone, we're going to be focusing on two special types of triangles today. So far we've been covering how to find missing angles in triangles and how we can classify triangles based on their angles. And then the other day, for day 2's lesson, we were covering a special theorem called the exterior angle theorem. So we're going to build off of that, focus it a little bit more on these two special types of triangles, isosceles and equilateral triangles, so that we can build upon the theorems that we've been learning. So for our warm-up, we have this diagram over here, and we're given quite a few bits of information. We want to find the measures of the missing angles. And in this case, our missing angles are going to be 1, 2, 3, 4, 5, 6, and 7. Now, I know from my first lesson that I can always find the measure of a missing angle if I have two given angles within my triangle. So I'm going to look to see, out of these missing angles that I have here, are they in a triangle where two angles are given, right? So I can focus on this first angle over here, and I'm going to highlight it yellow, just so we know which angle we're focusing on. Now, based on this notation, I know that this box in the corner means that this is 90 degrees, right? And I'm given that this is 40 degrees, and using my sum of interior angles theorem of a triangle, I know that the sum of the interior angles of a triangle are going to add up to 180 degrees. So I'm just going to do my simple equation, 40 plus 90 equals 180, right? Oh, sorry, 40 plus 90 plus angle 1 equals 180, right? And using this simple math, I know that I can solve for angle 1. So when I solve for angle 1, I can do 90 plus 40 is 130. So angle 1 is 180 minus 130, which is 50 degrees. Right? I'm going to put my work for angle 2 right next to this little part for angle 2. Right? So something else I noticed, right? So I'm going to move on to where angle 2 is. And I see that there's a vertical angle being formed with this given angle of 90 degrees right over here, in angle 2. And I know from my previous unit 1 that vertical angles are going to be congruent to each other. So I know that the measure of angle 2 is going to be the same as the measure of that given angle of 90 degrees. So I know angle 2 is 90 degrees because vertical angles to our given angle of 90 degrees. Right? So let's move on to angle 3. Now that I know that angle 2 is 90 degrees, right? I'm given two angles of a triangle, so I can use my triangle sum theorem to figure out what angle 3 is. I'm going to set up my equation with my given angles. 90 plus 30 plus angle 3 is all going to equal 180. When I combine my like terms, 90 and 30, I get 120, and I'm going to subtract that on both sides to figure out the missing angle for angle 3. So I get that that is going to be 60 degrees. We also covered a theorem yesterday where we learned that the two acute angles in a right triangle, this would be a right triangle because I have a right angle, are going to sum to 90 degrees. And I know that 30 plus 60 sum to 90 degrees, so I know I did that correctly. So I'm going to annotate that I know that this is 60 degrees. Right, I'm going to move on to angle 4. I notice the same kind of relationship that I noticed with angle 2 and angle 90, right? So I'm going to write that angle 4 is also going to be 60 degrees because it's vertical to angle 3. Somehow my handwriting is so much worse, right? Okay, now I know that angle 4 is 60 degrees. Once again, I'm going to annotate because I love annotating. Helps me keep track of my work, right? I notice that my other angle is 60, right? So I see that this angle 60, this angle 60. I know that when I have two 60-degree angles in a triangle, it's going to be an equal angular triangle, meaning that angle 5 also going to be 60 degrees. Not only is this an equal angular triangle, we're going to cover later on that this is also going to be an equilateral triangle, meaning that all three sides are going to be congruent in length as well, right? So once again, I'm going to annotate my work. This is 60 degrees as well. Oh man, look again. Angle 5, angle 6. Looks like we have a vertical angle pair again, so this is also going to be congruent in measure. So angle 6 is also going to be 60 degrees. Let me annotate that on my diagram just so I can keep track of my work. And then finally, in my last triangle, I have that one angle is 60 degrees. That's my angle 6. And I have another given angle is 20 degrees. So for my last angle, angle 7, I can use my triangle sum theorem again to figure out what my missing angle measure is, right? So I know that I have 60 plus 20 plus the measure of angle 7, which I'm just going to write as angle 7, equals 180. And I can do my simple math again to solve for angle 7. I know that 60 plus 20 is 80. I'm going to subtract 80 on both sides. And when I do that, I get that angle 7 equals 100 degrees. Okay? So I was able to use all the information that I've covered in units 1 and 3, and specifically utilize my idea of the triangle sum theorem, where the interior angles of a triangle sum to 180 degrees over and over again in order to figure out what my missing angles are going to be based on this diagram. So we covered a lot of information. Let's try to move on and focus a little bit more on these special types of triangles. So we covered the other day that when we have a corollary, we can think about it as a baby theorem, right? So this is derived from our big theorem of the triangle sum theorem, right? But for an equilateral triangle, if a triangle is equilateral, then it's equiangular, which is what we covered briefly in our warm-up, meaning that if all three sides are congruent, right, all three angles are also going to be congruent, right? For our equiangular triangle corollary, it says that if a triangle is equiangular, then it's equilateral. So we can always think about equilateral and equiangular being one and the same almost. We can use them interchangeably, right? So if all the angles are congruent in a triangle, then the measure of each angle is 60 degrees, right? We can think about it as, if we don't know the measure of one angle, right, we know that all three angles are also going to be the same, so I'm going to represent that with the variable x. And I know using my triangle sum theorem that x plus x plus x should equal 180. And then if I were to solve for x, right, I could combine my like terms to get 3x equals 180. Solve for x on both sides by dividing by 3 and get x equals 60. So that's how I can derive that in an equiangular or equilateral triangle, all three angle measures are going to equal 60 degrees. Okay, let's work through some examples where we're actually working with our equilateral or equiangular triangles. Okay, so looking at this diagram of example 1, I know that based on this diagram, it uses these tick mark notations, and we've covered that in unit 1. When we have a tick mark, we have congruency, right? So it's saying that side KL is congruent to side LM, and that's also congruent to side KM, right? All three sides are congruent, therefore we have an equilateral triangle. And we know from above with our corollaries that when we have an equilateral triangle, it's also going to be equiangular, so our angle measures are going to be congruent. So let me just denote that this is congruent to this and this, right? I'm given the measure of one of my angles, right? So I know that it's represented with the expression 2x plus 32. Whoops. 2x plus 32. Strike one for me. 32, right? And I know that it's going to be the same for angle LKM and also for angle LMK. So what I'm actually going to do, instead of writing 2x plus 32 plus 2x plus 32 plus 2x plus 32 equals 180, I'm going to write that 3 times 2x plus 32 equals 180, right? If I divide by 3 on both sides, I get 2x plus 32 equals 60. And that makes sense, right? Because we discussed that in an equilateral triangle, that every angle is equal to 60 degrees. So if one angle equals 2x plus 32, then 2x plus 32 equals 60, right? So if I'm solving for this, I get 2x. I'm going to subtract 32 on both sides to get 28. And I get that x equals 14, right? Let's try our next one. So practice problem. Once again, I'm using my properties of equilateral triangles. I'm actually going to use this second step where I have 2x plus 32 equals 60 as a shortcut, right? So I know that this angle measure should really equal 60 degrees because I have an equilateral triangle as denoted by my tick marks. So I know that one angle has to equal 60 degrees. So I'm just going to set this angle measure 4x minus 20 equal to 60. I'm going to solve for x, right? So I'm going to add 20 on both sides using my inverse operations. I get 4x equals 80, divide by 4 on both sides, and I get x equals 20, and I'm done. Let's try out the second practice problem, right? Now, I see, based on this diagram, that all three angles are congruent to each other. So I have an equal angular triangle. If I have an equal angular triangle, then I must have an equilateral triangle. So I know that this side, and this side are going to be congruent to each other, right? So I'm just going to denote that on my diagram so I know for myself. Now, if all three sides are equilateral, if all three sides are congruent, that means that this length, 5y minus 6, is going to be congruent or equal in measure to 4y plus 12, this side OP, right? So I can set those measures equal to each other, and I can just go ahead and solve for y, right? So I'm going to add 6 on both sides, right? I'm combining it with my like terms. I have 5y equals 4y plus 18, subtract by 4y on both sides, and I get y equals 18, right? Now that's not really what the question's asking for though, right? It's asking for side length OP, and I know that OP is being represented by this expression 4y plus 12. I know what y equals now, so I'm actually going to substitute that value in. So I have 4, instead of y, I'm going to write 18, substitute that value in, plus 12, keep everything about the expression the same, right? I'm going to do 4 times 18. 4 times 18, what does that give me? 72, yeah, 72 plus 12, there we go. I'm going to add 72 and 12 together to get 84, and that's going to be my side length OP. Okay, let's move on to the next page. Oh, lost in space. Okay, now we just covered equilateral triangles. We're going to cover another special type of triangle called the isosceles triangle, right? So for the isosceles triangle, we have 2 congruent sides instead of 3 congruent sides, like how an equilateral triangle does. And for an isosceles triangle, we have a very special relationship with the angles, right? So we have one angle called the vertex angle, and that's where our congruent sides touch, right? So our congruent sides touch to form our vertex angles. Now, the 2 angles that are at the bottom, hanging out by itself, not being formed by the touching equilateral sides or congruent sides, right, are called our base angles, right? And when we have an isosceles triangle, it turns out that our base angles are actually going to be congruent to each other, right? So knowing this, let's work on some examples, right? Let's look at this one. We want to name the legs, base, vertical angle, and base angles in each of the following isosceles triangles. So we know that this is an isosceles triangle, okay? So looking at this, right, I'm seeing that NL and NM are probably going to be congruent to each other because they're going to be equal in length, right? So I have NL and NM. And my base then will be my leftover leg, which is LM, right? So my vertex angle is going to be the angle formed by my 2 legs, right? And my 2 legs are forming this angle right over here, which is angle LNM. And I'm using proper notation, right? And my base angles would then be the ones that don't really have a buddy over there, but they're going to be congruent to each other, right? So I have angle NLM, and then angle NML. Okay, let's try this part out. All right, so I'm seeing that these 2 are touching each other, right? They're coming to this point O, right? And I also see generally they're going to be congruent in length, right? So my legs, I'm going to say, are OQ and then OP. My base is going to be my leftover leg, which is QP. My vertex angle, it's where my legs are touching, right? My 2 congruent sides are going to be forming this angle. So that's going to be angle QOP. And then my base angle is going to be those two angles that are hanging out at the very end of my legs, right? They're not touching each other. So that's going to be angle OPQ and angle OQP. Okay, let's try this one. All right. So I'm going to say that angle T and TR, sorry, side TR, oh, another strike. Side TR and side RS are going to be congruent to each other. They're going to be our legs. So I'm going to say TR and RS. My base is going to be my leftover side, so I have TS, right? My vertex angle is going to be formed by those two congruent sides touching, and I have TRS. And then my base angle is going to be those two leftover angles at the very bottom. So I have angle RTS and angle TSR. As long as you have S and T as the vertices for the base angles, whatever order you write the letters in doesn't matter, right? We covered that in Unit 1. Okay, let's try this one last example, right? I'm going to say ZX and XY are my legs. My base is ZY, it's my leftover side. My vertex angle is going to be the angle formed by my two congruent sides touching, and that's going to be angle ZXY. Could have just said angle X as well. And then my leftover angles are going to be angle XZY and angle XYZ. Great. Let's move on. Let's try out an example. So we want to find the measure of the vertex angle of an isosceles triangle if the measure of each base angle is 80 degrees, right? So here's what I'm going to do. When I read an instruction like this, I usually get a little bit tripped up. So what helps me is just to draw an isosceles triangle. And I know that triangle just looks like a triangle, but with an isosceles triangle, I have these two congruent sides, and I'm going to say that these are my base angles. Now, for this example, it tells me that this is going to be, this measure given is going to be the measure of my base angle, right? So I'm just going to annotate this as 80 and 80, right? So I know that 80 plus 80 plus whatever my vertex angle is, right? So let's say that my vertex angle is A, right? That's going to equal 180, right? Triangle sum theorem, once again, so useful. Now, I can see a trick, right? I can see that 80 plus 80 is the same as 2 times 80 plus A equals 180, right? Now, I'm going to subtract that. So I have A is equal to 180 minus 2 times 80. 2 times 80 is 160. 180 minus 160 is going to be 20. Okay? Let's try out the next one, right? Once again, I'm given that my base angle is 55 degrees, so once again, let me just draw a little diagram to help me out. So those are my base angles, those are my legs, right? 55, 55, I need to find my base angle, right? So instead of doing the first equation, right, that I set up originally with my triangle sum theorem, I'm going to move ahead, go over to my second, actually my third line of my equations, right? So I know that my vertex angle A, right, I'm going to represent it with A again. A is equal to 180 minus 2 times 55. Okay? And 2 times 55 is 110. 180 minus 110 is 70. So that's going to be the measure of my angle A. Okay? Let's move on. Now, instead of getting the base angle, right, now I'm going to be given the vertex angle. So I'm going to draw my diagram just to see what we look like. These are my legs. These are my base angles. Now, I'm given my vertex angle is 40 degrees. Okay. So I'm going to kind of work backwards from my example 2, right? I don't know what my base angles are, but I do know that they're going to be congruent, so I can represent them with the same variable, the same unknown. So I'm going to represent them with x. Okay? You could represent them with whatever letter, right? So I have 40 plus x plus x equals 180. Triangle sum theorem, once again, right? X plus x, my like terms, I can combine them to get 2x is equal to 180. I'm going to subtract 40 on both sides. I get 2x equals 180 minus 40, right? 2x equals 140. Divide by 2 on both sides, x equals 70. So that's going to be my base angle. So that's 70 degrees, right? I'm going to highlight this. I'm going to use this third line, right, as the basis of how I'm going to answer my second question, right, my second part. So I'm going to use this kind of like a formula, right? I have 2x. I know that my angle measure is going to be the same. My angle measure is being represented by this variable x is equal to 180 minus this vertex angle, right, 150. So I have 2x equals to 30 degrees. Divide by 2 on both sides. When I divide by 2 on both sides, I get x equals 15 degrees. So that's a little shortcut that I can use in order to help me find my base angles if I'm given my vertex angle. Okay, let's try this out. Find the measure of an angle, right? I'm given an isosceles triangle. I know that this is an isosceles triangle because I have these congruent tick marks, right? And so I'm given that these are my base angles then, right? Because they're not the angle formed by my two congruent sides touching. And so because these are my base angles, I know that these are going to be congruent. So I have that 3x is the measure of one angle. And if they're congruent, they're going to be equal in measure to the other base angle, x plus 44, right? So it looks like I can actually just solve this. So I have 2x equals 44, so x equals 22. That's not what the question's asking me to do though, right? It's asking me to find the measure of angle G, and I know that G, measure of angle G, is represented by this expression, x plus 44. I know what x is now, right? It's 22, so I'm going to substitute that in, not plug it in, because I'm not an electrician, not plugging anything into an outlet. So I have 22 plus 44 gives me 66. I'm talking about an angle measure, so it's 66 degrees. Got to be precise with my units. Let's move on to my next practice problem. I want to find the measure of angle N, right? So once again, I'm given that this is an isosceles triangle. This is denoted by my tick marks over here. I see that this is my base angle. This is my base angle because they're not being formed by these two congruent sides touching. So because those are my base angles are congruent for an isosceles triangle. So this measure, 6y, is going to be equal to this other angle measure, 8y minus 16. Looks like I can solve for this. So when I solve for this, I end up getting 2y equals 16. So y equals 8. That's not what the question's asking me though, right? I want to find the measure of angle N. And I'm given that the measure of angle N is being represented by this expression, 6y. I'm going to substitute in what I know for y now, 8, right? So 6 times 8 is 48 degrees. So this is the measure of angle N. Okay. We're so close. Look at this, we're so close, all right? Let's try out an example of a word problem, right? And then you're going to do a practice of a word problem together, okay? So the measure of the vertex angle of an isosceles triangle is 15 degrees more than the measure of each base angle. Find the number of degrees in each angle of the triangle. All right. I hate word problems in geometry because I'm like, half the time I'm like, what are you even saying? So just to help me, I'm just going to draw a diagram just to reference, right? So I'm going to look at some pieces of information to help me figure out how to draw this diagram, right? So I know that I have an isosceles triangle, so I'm going to denote these as my legs, right? My congruent sides. And then these are going to be my base angles, right? And in my first sentence, it's talking to me about the vertex angle, right? So the vertex angle, right over here, is going to be 15 degrees more than, right? So I know I'm going to be doing some addition over here, right? Because more than is a keyword for addition. Then the measure of each base angle, right? Let's say that the base angle is going to be represented by x, right? So each base angle. So if I'm going to write out an expression for my vertex angle, right, I know that it's going to be 15, right, 15 plus the measure of each base angle, which is represented by x. So I want to find the degrees in each angle of the triangle. So I need to find my base angle, and I need to find my vertex angle, right? Because my base angle are going to be the same measure, so I don't need to do the work twice, right? So I know that x plus this vertex angle, 15 plus x, is going to equal 180 degrees, right? Because of my triangle sum theorem. So handy. We love the triangle sum theorem, okay? So now that I know that I can set this equation up, I can combine my like terms. I get 3x equals, I'm going to subtract 15 on both sides to get 165, right? And when I do that, I want to divide by 3 on both sides, so I get x equals, oh, let me do this really quickly in my head. So I get 55 degrees, right? So my vertex, my base angle, which is represented by the value x, is going to be 55 degrees. And I know for my vertex angle, I had this entire expression, 15 plus x, that represented it, so I know it's going to be 15 plus 55 degrees. I'm going to substitute that in for x. So 15 plus 55 gives me 70, and that's going to be my vertex angle. Okay? This one's pretty similar, right? The measure of each of the congruent angles of an isosceles triangle is 6 degrees less than the measure of the vertex angle. Find the measure of each angle of the triangle. Now, once again, we're going to diagram. So I'm going to draw a triangle, an isosceles triangle, right? Because that's my given information. I'm going to set these two as my legs and these two as my congruent base angles. Now, it says the measure of each of the congruent angles, so that means my base angle, so let me just annotate that. My base angles is 6 less than, right? This less than tells me I'm subtracting the measure of the vertex angle. Okay, so it seems like I'm going to say that this vertex angle here is going to be v, okay? Find the measure of each angle in the triangle, right? So I know that this is going to be 6 less than the measure of the vertex angle, so I can represent this with v minus 6. This is going to be the same, v minus 6, and my vertex angle is a v, right? Triangle sum theorem, once again, I have v plus v minus 6 plus v minus 6 equals 180. All right, going to combine my like terms to get 3v minus 12 equals 180. Add 12 on both sides to get 3v equals 192. Divide by 3 on both sides to get v equals 64, right? So that's going to be my vertex angle. And I know that my base angle, I can substitute in this value for v now, right? So I have 64 minus 6. That's going to give me 58 degrees for my base angle, right? So this is my base angle. This is my vertex. Okay? You're free to do the challenge on your own, right? If you want to do the challenge together, let's try this out. These are my legs, right? So I know that these are going to be my base angles, so they're going to be congruent. This is also 65, right? 65 times 2 gives me 130, right? So 180 minus 130 is going to give me this vertex angle right over here, which is 50 degrees. So let me just annotate that as 50 degrees. I know that this angle, this vertex angle here, is going to be congruent to this vertex angle, to this base angle over here, right? So I know that they're going to be congruent because they're vertical angles to each other, right? They're forming that X that we see. Now, I know that this is going to be a vertex angle for this bottom triangle. Let me just highlight this bottom triangle so we know what we're talking about, right? So because this is a base angle, right, I know that this is going to be congruent. So this is also 50 degrees, right? So 2 times 50 is equal to 100, right? So 180 minus 100 is going to give us this value for x, right? So this is going to be 80 degrees for x, right? There we go. So we just needed to use a little bit more information about vertical angles, right? So let's just look at this exit ticket really quickly and then just go into a little bit of a summary of this lesson. So the measure of each base angle of an isosceles triangle is represented by x, and the vertex angle is represented by, right? Once again, let's draw a diagram so that we know what we're talking about. We have an isosceles triangle given by this information. So these are my legs. My base angles are here, and they're congruent, right? So each base angle is represented by x, right? If we're trying to figure out the vertex angle, right, we know that this is going to be 2x, right, plus something equals 180 based on our triangle sum theorem. And so we know that we can solve for this question mark, right, this vertex angle as 180 minus 2x, right? So going to be option number 4. And we talked about that in our previous examples, right? In the diagram of triangle ABC below, we know that AB, segment AB, so let me just annotate this, is going to be congruent to AC. So AB is congruent to AC, right? So those are going to be my legs. Therefore, these are my base angles, right? That's my vertex angle. Angle A is my vertex angle, right? So it tells me that the measure of angle B over here is 40 degrees. So that's 40 degrees of angle B is 40 degrees. I know that angle C is 40 degrees because they're base angles, and base angles of an isosceles triangle are congruent, right? So in order to figure out my vertex A, right, I can actually use the first problem in my exit ticket to help me out with that. I know that my vertex angle is represented by 180 minus 2x, right? Lo and behold, I know what this x is. I know that it's going to be 40 because that's the measure of my base angle. So I'm going to just substitute that in. 2 times 40, right? This is 180 minus 80, and that's going to give us 100 degrees, right? So this is going to be option 4. Okay, so for homework, right, you want to work on page 22. And 23, right? You have a lot of these diagram problems where you're trying to solve for this algebraically given the information you have, and then you have 3-word problems, right? Happy studying.